Welcome back everyone to Data Science for Everyone. Today we're going to be looking at quantile regression with stats models. Let's get started. So first off, we're going to be kind of replicating a little bit of a paper from Conker and Hollick called Quantile Regression in Journal of Economic Perspectives from 2001. Now we're going to be interested in a couple different things, okay? So specifically the relationship between income and expenditures on food. And so this is called the Engel data set. This data is actually all the way back from somewhere around 1857, 1850s, somewhere around there. Okay, so let's go on and get started with our setup. So first off, let's do import numpy as np, import pandas as pd, import statsmodels.api as sm, import stats models dot formula.api as smf, import matplotlib.pyplot as plt. Let's also do matplotlib inline, and I think we're going to be good to go there. Now the next thing that we're going to want is to go on and get the data itself. Whoops, and I misspelled formula. And so this data itself is data is equal to sm.datasets.engel.load.pandas.data. And let's go on and data.head. Take a look at it. Oh, head. And my keyboard is starting to die on me. I think the battery's starting to go dead. All right, so here we have income and food expenditure. Now, the first thing that we're going to want to kind of work on this is the least absolute deviation. Okay, and so this LAD model specializes in quantile regressions, where Q is going to be 0.5. So our model is going to be smf.quantreg, so for our quantitative regression, or quantile regression, sorry, food expenditure, and we want income. And we'll use this on our data. So then let's also go on and do our residual, or our results is going to be model.fit. And here we'll do Q is equal to, as we said before, is equal to 0.5. And then let's go on and res.summary. Okay, so here we can actually see our results. Now, everything seems to be doing okay. Our pseudo R squared is, again, we're at 60%, so it's not great. Now, what we'll want to do is let's go on and maybe visualize these results to see what we're actually wanting to do. So let me go on and put something here, such as visualize results. Now, we estimated the quantile regression model using our range was going to be between 0.5 and 0.95, and we're going to compare the best fit line to each of those models to an ordinary least squares result. So let's go on and let's actually write this out a little bit. So quantiles is np.a range 0.05 to 0.96 by 0.1. And then we want to actually define a fit model in here. It's going to take some quantile, and here we'll do our results is equal to our model.fit, Q is equal to Q. And then we want to return in here Q such that our results dot parameters, the intercept, our results dot parameters dot income. Then we want to add in our results dot our confidence interval. dot loc for the income. And we want to take this to a list. Okay, and I think that'll be okay for you guys. And then let's also go on and do a couple more things. We want models is equal to fit model of x for x in quantiles. So what we're doing is we're using list expansion in here. Okay, so we are, and we're going to do this for each of our quantiles. So we'll have a range in here of from 0.5 to 0.96 or so, actually to 0.95 technically, because it's up to but not including this, and we'll be going up by 0.1. So we're actually going to be running quite a few models in here. Models is equal to, and this is going to be easier to do this as a data frame. Columns in here will be something like, what do we want to do? Let's do Q, A, B, LB, and UB. Okay, and then let's actually go on and do our OLS. With our food expenditure on our income. Then we want data, we want fit. Then we're going to do our OLS confidence intervals. Dot location for this, we want where the income is. And then we want this to a list as well. So OLS, and we're going to do this, we're going to set up our results as a dictionary. Do I want to override it? Let's do OLS.dict for now. So dict here, A is equal to OLS.params of the intercept. We want B is equal to our OLS.parameters of our income. Oh, and this is lowercase income. And then we'll do LB is equal to OLS CI of naught. And then we'll do our UB is equal to OLS CI of 1. And that will be the end of that particular one. So let's go on and also print out our models. Let's also go on and print out our OLS dict. Oh, and what didn't it like here? Well, let's go see. Fit model is not defined. There we go. So now we actually have our our actual models themselves, as well as with the dictionary of our outcomes. Now let's also go through and do our first plot. Okay, so here let's do first plot. And this is going to be, we'll show the best fit line for 10 quantiles, quantile regression models. Okay, to the least squares fit. So let's go on and do that. Now, let's see what we have here. X is equal to mp.arange, data.income.min, data.income.max by 50. Okay. Then we also want in here our get y. So let's go on and do a lambda expression for this. So lambda a b such that a plus b multiplied by x. Let me give that a little bit of space so it looks a little bit better. Then we want to also do our figure and our axes. So plt.subplots. Fig size in here, let's make this a 10 by 6. Then we want for, let me give it a little bit more space in here for you guys, and let me zoom in just a little bit more. So for I in range, we want our models dot shape of 0. Again, so the reason I'm doing this as generically as possible. Again, maybe we want to make some sort of function for this later on if we're going to be doing a lot of quantile regressions. But I'm making this so that it's as generalized as possible. Again, while we're typing this out right now, y is equal to get y, and we have our models dot a of I, models dot b of I. Our axis, then we want to go on and plot x, y, line style in here would be something of a dotted. Our color, let's go on and make this gray. All right, so y is equal to our get y, OLS of A, OLS of B. Then we want what? Let's actually go on and do the plot itself, okay? So this will show us kind of all of the variables, so all of the variations, let's say, of our plot, so at least each of these quantiles. So ax dot plot x, y, color is equal to red. And this is going to be just this will be the OLS plot. Then axis dot scatter. Here we want our data dot income, our data dot food expenditure. Alpha is equal to 0.1. We want it nice and light so that they're kind of see-through. Axis dot set our limits, our x limit. And here would be, let's do 240 by 3000. Axis dot set y limit. And here we want, again, 240, but let's do it by 2000. Then let's go on and also set up our legend. And then axis dot set x label. Here we want income, font size, let's give it 18. Axis dot set x y label is going to be food expenditure. Font size here of, let's do 18. Let's give that a try now. Let's go on and see where we messed up. Regression wrapper is not subscriptable. All right, so we have this. This is starting to get it, but let's go on and actually go through our issue, which is right here. And what actually happened. Should be OLS dict. And there should be probably another one. Income. All right, let's see here. Where is it saying this? No attribute income. Scatter. Income. There we go. Oh, we have all kinds of little issues here. Has no attribute food. And again, my guess is probably while I'm typing all of this out, you guys are just screaming at me for this. Again, my typing skills are kind of abysmal at the moment. All right, so there we actually have it. So now we actually can see here the actual plotting, where we can see on here all of the different quantile ranges that we've actually plotted out. And then we also have in here our actual OLS line. And again, you can see that based on all this, basically we're giving ourselves almost a big range as to how each of these would do. Now, none of these are exactly good by any means, but let's go and make out maybe a second plot in here, and we'll have maybe our quantile ranges in there as well as our confidence intervals, that type of stuff. Now, in most cases, okay, our quantile regression point estimates are going to lie outside of our OLS confidence, as we can kind of see here, okay? So again, you can probably assume that our confidence intervals are going to be somewhere here, and we'll show that here in just a second. Now, we'll talk about maybe what this suggests in just a second. So let's go on and get this plot started. So n is equal to our models dot shape of 0. P1 is equal to plt dot plot models dot q models dot b. Color in here will be black. Label is equal to quantile regression. Then let's go on and put P2 is equal to plt dot plot models dot q models dot ub for the outer line. Style in here, we want this to be dotted. Color is going to be black. Again, this is to match this B here. Now we'll see that P3 is going to be, and I'm going to just copy this line, and this is going to, we're going to change this to our LB because again, we want to have our outer ranges, and we can maybe run that real quick. Oh. You can see at least here up, and that's his line. Whoops. Style. So now you can actually see here we have our outer ranges. Now let's actually go on and put this comparison in for our OLS regression as well, okay? So if we want to compare that, so then here is the OLS, and here, this one was the quantile regression. So P4 is equal to plt dot plot models dot q, and here we want OLS dict of B multiplied by n. Color is equal to red. Label is equal to OLS. P5 is equal to, and I'm going to go on and just copy this, and this will change to BL, and this will change to BU, and this would be P6. And then we need to go on and change, get rid of this, get rid of that. And what do we want in here? We need a line style. Line style of dotted. I'm going to copy this as well. Put that down here. And then we want to also go through and do something a little bit differently. So let's do plt.ylabel in here is going to be a beta income. I think that should be fine. And then do BLT X label here, and we'll do quantiles of the conditional food expenditure distribution. Then a plt.legend, and then we'll do, I think that's good. Whoops. I don't want that. Oh, what flags is it running here? 8 missing current font. Oh, if I do turn this to a raw, will that work? It's okay. I'm not gonna worry about it right now. Usually this should actually have a beta in there. I think I just don't have the correct packages put in. So what we can see here, all right, is this dotted black lines form the 95% pointwise confidence band around the 10 quantile regression estimates. And so that's going to be this solid black line here. Now the red lines are going to represent our OLS regression results within their 95% confidence interval. So again, we can see here that, again, this is just kind of in summation on this. These quantile regression point estimates lie outside of our OLS confidence interval. Now, which is going to suggest that the effect of income on food expenditure may not be constant across the distribution. Okay, so that's going to give us a little bit of food for thought when we are working on this. If you guys like this, please comment, subscribe, and hit that like button, and I will see you guys next time. Bye-bye.